Okay, hello everybody. We're going to be working on similarity and transformations today. Are you guys excited?
Yes.
Cool. All right. So now, I would like Tusran, will you read the first line of today's standard, please, while I start handing stuff out?
Given two figures, use the definition of similarity in the given similarity transformation to decide if they're similar.
Is it? Oh, hold on. Okay. Sorry.
Explain using similarity transformations the meaning of similarity for triangles as the equality of all corresponding pairs of angles and the proportionality of all corresponding pairs of sides.
Okay. Did you read the first line or all of it? Oh, okay. There's the first one, but that's fine. All right, so what we're going to be doing today is we're going to be taking a look at that. You notice I gave you guys a bunch of these little cardboard things. We're going to be starting off today with a roaming activity where you'll be matching these shapes using these similarity rules we've discussed already. We're then going to be doing some group work where you guys will be drawing some stuff on the grid paper scattered around the room, and then we're going to share our work. So let's get started. Everybody stand up, please. All right. I'm going to give you guys 4 minutes. Your goal is to find the person with the shape similar to yours and then sit at one of the 4 tables with whatever's. And let's go. Now, I have one, so if you're stuck, feel free to...
Who's equilateral?
Equilateral.
I think it's you and I.
Okay. And then we just pick one of the 4.
Pick one of them, yeah?
Okay.
No, I think you guys are.
Wherever you want.
No. Sit back there so it's so cool.
I have one. You guys need
Okay, so we have set up one of the spots.
pick a spot. Yep. Spot.
I think, yeah.
We got one. Are we matching? Okay, so what are we doing? How do we figure out if we're matching? Size? Or what? Okay. All right, so let's what do we do there? We did one angle. So what else needs to happen?
The sides.
The sides? We don't have any numbers. How are we going to tell if the sides are related in any way?
Measure.
We don't have any tools right now. So what are we working on? We only have the angles, right? We just did one angle. Could we do the next one? All right, so we got 2 angles. What else needs to be true for things to be similar? All the angles. All right, cool, perfect. All right, so let's take a seat. All right, cool. That did take 4 minutes, which is good news for me. Very nice. So let's talk about that, right? What did we compare? How did we figure it out? Daniel, what did we do?
I used my eyeball.
That's eyeballs are great. Eyeballs are not math. So what math concepts were we working on? What do we have going on over here?
Side,
Side angle side, okay.
side.
Side, side, side. Do we have any congruencies, or what were we looking at there?
Yeah, we do.
We do? What's congruent?
The sides.
Are these sides congruent?
Yeah, I
Those
think
don't work.
so.
Let's use Daniel. Let's use your eyes. Do we have any congruent side lengths?
No, but they probably have congruent angles.
Oh, we got the angles. Is that what we were looking at? Who else was looking at angles? Who else was doing the
After the fact.
after the fact, sliding around?
After we
Okay. Again, it's a little tricky. If we did an actual lesson, probably even easier there. But that was the idea, right? We were comparing the angles. We were moving the shapes around, translating them, twisting them, flipping them, keywords. It's pretty great, right? Now we're going to get into the hard part. Group work. You guys all have a piece of graph paper, a protractor, and a compass. What I want you guys to do now is you're going to trace your 2 shapes on this graph paper somewhere. You're going to identify one as image, one as pre-image. Okay? Those are the key words. Remember, image is what happens after we do a bunch of transformations. What's the pre-image?
Before.
The original, before the transformations. Exactly. Now you guys then need to identify which transformations you use to match the 2 shapes on top of each other. that's what we're gonna do next. And make sure you draw all stages. So if you do one transformation, you should only have image, pre-image. But if you do multiple transformations, you need to have multiple sketches. All right, let's get to work. I'm gonna just sing it. If you guys want a challenge, try to use an actual rotation. All right, let's get the timer going. Misbehaving. I'm gonna give you guys 6 minutes. All right, let's take a look. Very sorry you got the short end of the stick. You only got to do one. But if you get stuck, just flag me. I'll take a look. We'll help out. Cool. Right. So which transformations do we think we're going to end up using a lot of? What do you think? Dilation, yeah. Why do you think that?
Because the shapes aren't the same size.
Not the same size. Very good. All right. Very nice. That's very good. It's a little tricky. Yeah. Good. Yeah. Once you get all your shapes down, then we got to figure out some key stuff. Right? Keep in mind, your guys' protractors do have measuring tools on them. These were measured using centimeters, the metric. So if you guys need to figure out stuff in order to get that dilation, remember dilations have two trends. What do all dilations have? What's the number? What do we call that thing? Yeah, when you do a dilation, everybody can we look over here for just a moment, please? When you do a dilation, there's a number corresponding to that in order to change the size. What do we call that number? The scale, right? So we're going to need to figure out that scale factor. So make sure we figure it out. That looks real nice. I like that. Cool. So make sure you measure. Everything was measured pretty reasonably. Everything's in centimeters. Centimeters on the inside, yeah. So make sure you guys figure out your scale factor so you know what that transformation is. Let's check the time real quick. All right. You guys have 3.5 minutes, plenty of time. All right.
So then, number 2 is
Looks good. Very nice. Very good. Very nice handwriting. I love it. Looks good. How we holding in there? Doing okay? Very nice. Good. Okay. How we doing? How we doing? We doing okay? Yeah? Yeah? So you guys are measuring in inches, which is fine. You should be able to get there, but I did measure them all in metric using the inside. That's fine. You should get the same scale factor. Because the scale factor is a ratio, which means the units don't matter. And these were all handmade, so if it's a little clumsy, then it is what it is. Yeah. That's good. What do we think? You got it?
I think so.
Yeah.
I think for us,
Mm-hmm.
if we draw it like this, the only transformation is dilation.
Yeah.
This is 0, 0. Everything
Yeah.
is a whole.
Very good. Excellent. Very nice. Yeah, so you measured 3 and 6 inches.
I got 8 and 16.
Exactly correct. How are we doing over here? Are we okay? Yeah. What are we measuring? The angles? You can do that, yeah. It's not necessary for what we're looking at, but very cool. What have you guys got so far? Yeah. Very cool. Very nice. Good stuff. Okay. How we doing? guys stay. You got yours. Still finishing up yours. Two Trent, how we doing?
Yeah, 5 minutes.
5 minutes left? You doing okay? Yeah? Yeah? What did we end up with? Oh, okay. Yeah. I should have also thrown some calculators. I have like 3 scientifics floating around in my helmet. What are we looking at? How we doing?
We just got the metric measurements.
Yeah? Yeah?
We're just getting the ratio.
Yeah? Cool, cool.
Well,
Mm-hmm.
they're all
You can use the calculator on your phone if you need to. All right, 30 seconds. Make sure you guys put your finishing touches on whatever you're looking at. Mhm. All right. How we do? What do we get? We find our scale factor? No?
Let's just round this.
Why not? Where we step?
Yeah, so 4
Well, it's a ratio between sides, right? So do we have any sides that we know are supposed to line up with each other? Yeah, so if we make the ratio, right, what's that ratio? So 1/2. Perfect. All right, everybody, attention up here, please. Okay. All right, so now what we're gonna do is I'm gonna have you guys come up and share a little bit of your work. So let's start. We'll just start closest. I'm sorry. Let you guys come up and talk a little bit about what you guys figured out. 3 minutes, 4 groups.
So we measured both of our triangles and
You can put it on the Elmo if you want.
so we measured both of ours and we noticed that they both matched by half, which gave us a scale factor of half.
Cool. Very nice. Looks like you guys measured some angles too.
Yes, we did.
Cool. All right. 2 training next? All right, let's take a look. Okay.
Okay, so this is my pre-image, so then I did translate 18 units up here to get to the image itself. And then I measured, this is the inches and this is the centimeters, so this was, the smaller one was 6.5 and this was 9.5, and then I divided it to get the dilation scale.
Very nice. Okay. Looks good. Yeah. Notice that the translation also had a number attached to it. Remember, a lot of these things should have some extra piece of information connected with it. Thank you, Chutran. All right, you guys up next.
So I really didn't want to like do any translations, so I drew the smaller
2
one.
minutes, 2 minutes left.
I drew the smaller one inside the large one, just did one big dilation,
Mhm.
which was a factor of 2. So it's basically
Very nice. Because remember, technically dilations need to have a starting point. You have to be dilating through a specific point.
Oh,
They
yeah.
dilated through
Yeah.
one of their
You said
vertices.
that this corner was the origin, and then everything else was just
Beautiful. Excellent work. All right, let's take a look. What do you guys got over here?
Yeah, so we just did the scaling as well. So comparing the pre-image to the image, we increased, the scale is 4. So if you see in the pre-image, the measurement is 4, 6, and 8, and then increasing 4 on the bigger one, and it's 6, 10, and
Okay. So it looks like you guys did you went from 4 to 6 to 8. Is that what happened?
we went somewhere.
Yeah. It's supposed to be a multiplication thing, but that's fine. All right, excellent work. All right. Thank you, everybody. You guys did an excellent job today. I saw a lot of good work. I saw a lot of great math taught. A lot of clever ideas going on with the measurements and the vertices and the translations. It looked great. Thank you guys so much. I hope you guys have a wonderful day. You do have a 47-page homework assignment after this, so make sure you get that into me before the end of the night. Thank you.
great way to start. Daniel, you're up. You have a couple minutes to get it going.
Would you like